Number 3. Mr. Kelly's company manufactures a cylindrical soup can that has a diameter of 6 inches and a volume of 226 cubic inches. If the diameter stays the same and the height is doubled, what will happen to the can's volume? Let's look at that. So we have a can of soup. And it says that it has a the base has a diameter of 6 inches. So that's 6. And it says that the volume is equal to 226 cubic inches. So what I'm wanting to find out is if the diameter stays the same and the height is doubled, what will happen to the can's volume? Well, I don't know what the height of the can is, but I can find out. If I go to my formula chart, I see that the formula for the volume of a prism or a cylinder volume is equal to big B times little h. And you all should know that big B is the area of the base. So if I plug in my information here, volume equals big B times h. I know that the volume is 226. I'm just plugging in up here. Volume is 226 equals big B, area of the base. That's not just 6, guys. It's the area of this base. It's the area of that circle. And the area of a circle is the area of a circle. You should recall, at least it's on your formula chart, is pi r squared. So I have pi times r. If 6 is the diameter, then 3 is the radius squared times my height. And that's the variable that I'm looking for, that I don't know. So what I'm going to do here is pi times 3 squared is just some number. So I'm going to divide by that. I'm going to divide by pi times 3 squared. Divide by pi times 3 squared, because it's all being multiplied right here with h. This goes away, and my height is equal to. Now I could have simplified this 3 squared to 9, but I'm just going to let the calculator do the work. When you're dividing something and the bottom number, or the top number for that matter, if it has more than one thing in it, like here we have 9 times pi, or 3 squared times pi, put that in parentheses, because if you don't, your calculator knows the order of operations, and what it would do, well, let me just show you. Here I get 7.99. Well, I'm just going to call it 8. Let's do the same thing real quick just to show you what your calculator would do if I didn't put the bottom in parentheses. It doesn't give me the same thing. What this did was it did 226 divided by pi, and then that answer times 9. So make sure, because see, we wanted 226 divided by the whole 9 pi, or 3 squared times pi. So put that bottom in parentheses. So we have the height of our cylinder is 8. So the question again was, if the diameter stays the same and the height is doubled. So now I have this cylinder here, a new cylinder. My diameter is still 6, but my new height is now doubled. This height is 8. So my new height is going to be 16 because I'm doubling it. So what happens to my volume? Well, volume again is equal to big B, which is area of the base, which we've determined was 9 pi, because the radius is 3, area of a circle is pi r squared, so it's the same as this. I've just simplified the 9 pi times the height, which is 16. So 9 pi times 16 is equal to 452.4. So let's look and see what happened to our volumes. Here we have 226. Here we have 452. It looks like it doubled. The answer is B. So if the if the cylinder's base stayed the same, but the height was doubled, the volume doubled. This is a problem that simple common sense could have been applied rather than doing all the work, but I wanted to show you the work as well. If I have a can of soup and the base stays the same, the diameter stays the same. If the diameter stays the same, then the area of the base remains the same. Then if I double the height, which means I'm just going to take another soup can of the same base and stack it right on top of there, then you should see that the volume will be doubled.